Hello, everyone. This is another edition of 3D Printing News Unpeeled with yours Peels and 3dprint.com. So today, for our 3D printing news roundup, we have a number of stories, most of whom are involved in space. So that's a very exciting additive manufacturing 3D printing area, and it's really showing up in today's news roundup specifically. So the first thing is that Blue Aerospace is going to be using Farsoon 3D printers to produce rocket engine components. So Blue Aerospace is a Chinese reusable rocket company that raised over 31 million in funding. It aims to, at one point, produce 85% of its rocket propulsion components using 3D printing. And it wants to start its own AM factory, AM facility to do this at. They've currently, for their liquid oxygen kerosene engines, printed a number of components using Farsoon's FS621M printer, which is a large-scale Farsoon powder bed fusion system. Now, this is notable because, well, first, if we're talking about new space or the commercial space race, it's almost always American companies, and American companies using usually also American or European equipment. So first off, yes, there is a space race going on, but it does not only involve American businesses, even though these are some of the largest and most well-funded. There's Chinese companies playing in this space race as well, and they're using Chinese 3D printers. So will China's development in space develop its own indigenous 3D printers? Because it's quite clear that Chinese companies will have a strong preference for Chinese-owned and Chinese-made 3D printers, especially in stuff like space. It's very sensitive and very adjacent to rocketry and ballistic missiles and things like that. And it's also very clear the Chinese government wants to promote China's advancement in additive manufacturing and getting better printers. So it would really make sense as well from a funding perspective for these guys to bet on China. In this case, this is notable. The rocket itself has a 780 millimeter height, is 550 millimeters in diameter. It's just the combustion chamber. As we've seen many times, combustion chambers are being 3D printed in considerable numbers. Nearly all of the commercial space companies, I actually think it's all of the commercial space companies, but it's definitely nearly all of them, are using 3D printing specifically for these combustion chambers. It's made out of Inconel, which is a very exciting material, very well-used material in that area. And the company, Blue Aerospace, says that part consolidation is a major reason for doing this. Lightweighting lattices is being used, and they have complex geometries is also really a reason to do this. And one of the things that they've done is they have internal cooling ribs and channels in this thing, which is also quite par for the course for this kind of a thing. So, yeah, we're seeing a divergence of the 3D printing market with China and the rest of the world. China betting big on China and defense and adjacent industries. And, but are we going to see these type of Farsoon systems being sold internationally? We don't know. Are people going to take a risk on a company that's relatively new and relatively unknown in this really large-scale space? Are they going to use these applications to leapfrog into Europe and stuff like that? I don't think so anytime soon, but we see more of the Farsoon selling kind of more entry-level systems and this kind of thing, along with the other Chinese providers. At the same time, is that something that's going to happen in the future? Or are we going to see a completely American-dominated space industry and then a Chinese one? Well, there's also an alternative, and that's a more international alternative. This is, by the way, is the combustion chamber for Blue Aerospace. And this is a remarkably similar-looking thing from Agnikul Cosmos. And Agnikul Cosmos is an Indian company. So we should not forget that there is a big world out there, and the Indian space program has been very successful, and then not only very successful, but very successful at being very inexpensive and successful, which that kind of frugality can translate very well into companies using money very wisely and very in a spendthrifty kind of or in a really intelligent way to really make good solutions. Now, what Agnikul Cosmos says is that it's making a 5-component rocket engine out of one piece, or out of simply all of the 5 components are 3D printed. It says it's entirely 3D printing a rocket engine, which some companies, and I've said publicly, are kind of doubtful that they've done this. But for this cryogenic liquid propulsion engine being 3D printed in India, in 5 pieces in 96 hours is a hell of an achievement, and a hell of an achievement for them to kind of, be able to match the space race with much, much better funded competitors. This rocket's going to have be a part of the Agnikul, which is a satellite launch vehicle. And the company, again, is talking about parts consolidation, but also, and often overlooked, but just like compressing this process into just one process, the 3D printing process, and then not having to do all these other processes like welding and joining and all sorts of other machining processes. So that really reduces your process complexity and lets you be excellent with much less effort. I think that's a really important point that they made in this release. The other thing is the company says that it has a patent for this engine. I haven't really properly looked at the patent, but this is something that a lot of people are now coming to terms with, that there's certain things we can do with 3D printing where in certain cases some patent authorities may allow us to patent certain geometries, which could be optimal geometries, or certain patent authorities may allow us, let us patent like 3D printing X component. And this really points to very, very patent-specific kind of problems that maybe these rocket guys will have and maybe have to engineer their way around going forward. So I thought that was quite significant thing to consider. Lego has made its first 3D printed brick. It's the thing on the left, and it's a duck. And this duck is made out of, we don't know yet. We don't know the printing technology specifically. We don't know the material. By looking at it, I think it does look a bit like Evolve Additive. Tell me what you think in the comments, or because I'm not entirely sure what it would be or what technology it would be. I'm betting it's an Evolve, but it could be something else. But it's not like a brick in wide circulation. This is just a brick. It's kind of a test thing. This is destined to become a collector's item. And it's called a Lego house event, which is kind of like an aficionado kind of event for people who are like collectors of Lego and these kind of things. They come here and they made this special component for them. So yeah, this isn't like a commercially available part. This is not a generally available part, but we know that Lego has been doing a lot with 3D printing. We expect Lego to be doing a lot with mold repair, conformal cooling, since they're such huge users of molds. Yeah, so mold rejuvenation, like putting a new layer using DED on a mold and then machining it down to lengthen the life of this mold is a very logical thing for them to be doing. Conformal cooling is often talked about, but for Lego's case, they use so many molds and they use them so intensively that any kind of really small adjustment in cycle time is going to be huge for them, especially since for a lot of things they're making a very limited geometry over and over and over again, standard bricks. So where does 3D printing fit in the picture? Is this a marketing exercise, or are they going to 3D print all the parts in the future? No, we don't know this at this point. It would make sense for Lego to make certain really, quite low volume bricks at the moment, especially if it could sell them at a premium, and especially if they do things that other bricks can't do, or they're really particular things that allow for a functionality that other bricks can't. We don't really have the economics to match like mass injection molding things yet, nor will we have them for the foreseeable future. So at the moment, it's just something that that is nice to see and nice to know that they're working on it. Nice to know that Lego has deep 3D printing expertise, but we don't. Yeah, we didn't get a step closer to 3D printing billions of Lego bricks. So the next news is again from aerospace, a little bit differently. SLM Solutions has gotten a subcontract from Concurrent Technologies Corporation, which got a $5.2 million contract from the Air Force Research Lab to develop a large 3D printer. And what it's doing is it's subcontracting. Hopefully a big chunk of that is then going to go to SLM Solutions to make a bigger machine. And so the Air Force, for some reason, wants a machine that's bigger than the NXG 12 3D printer. The NXG 12 600 is 600. It's 600 millimeters by 600 by 600. What has been disclosed is that they want the Z direction to be 1.2 meters. So that is going to be quite a considerable size build volume printer. It's going to be quite expensive, I would think, as well. It's also going to be quite expensive to run. So one would assume that the Air Force Research Lab has some capabilities for larger vehicles of some kind that it really wants to see printed. Enough to get a company or two companies to work together to make a much bigger printer. So this is again huge. I mean, we know that for aerostructures, for hypersonics, for satellites, for satellite components like RF components, for different kind of communications components and radar components, we know that 3D printing is going to play a huge role, and we know that also for drones, it is playing a huge role at the moment as well. And yeah, the U.S. Air Force is going to put its money where its mouth is. Now, the really new thing about this is that, well, this contract has been granted to SLM, which is a German company, which is in the process of being acquired by Nikon, which is a Japanese company. So this is a sign that maybe the United States is comfortable to play well with its allies and to play well with the foreign companies to secure key technology, right? Now, again, probably the United States Air Force wants to stimulate several companies to operate and be able to print accurate, really large parts because of a real need. There's probably, the only reason they're doing this is there's a real need. This isn't some experimental thing. They need to build something that we can't make. And they probably want to stimulate several companies to do it. So this is probably a thing. But at the same time, this is a really good sign, I think, that the United States feels comfortable enough to give this funding to a foreign company, whether it be Japanese or German, to stimulate them to make larger scale 3D printers. It really points to them having kind of like an allies or preferential towards allies strategy rather than a US only strategy. So this is good, I think. And probably this using this Concurrent Technologies Corporation, which is exactly as mysterious as you think it is, that also adds a layer of security, and being able to do all the secret stuff will probably be done by that company. So we don't know what it's going to be doing. We probably will never know what this is going to be doing. But this is a really great sign. Now, it's not a good sign for 3D Systems, because 3D Systems was making a DMD printer with the Air Force. I think they started on that like 2015 or something like that. So, they would have liked to get this money as well. Now, again, the Air Force may be doing it concurrently, so funding the 3D Systems effort and some Solutions one. And also, it's not really great for the GE Atlas system, because that already has a really tall build volume, and that was also not chosen for this. Now, again, the Air Force probably wants a couple of players in the field, but again, this is a significant win for SLM Solutions in this kind of large-scale printing arena. And I think it should be seen as this. And it's really remarkable. I think it's remarkable that the United States government's looking for allies for technology, rather than just having a U.S.-centric only approach. But this is a great day for aerospace and 3D printing, and it really shows you how what is possible and what will be possible in propulsion units and missiles and a lot of other components going forward. And thank you so much for listening. My name is Joris Peels, and this was the 3D Printing News Unpeeled, courtesy of 3dprint.com. I'd love you to have a really, really great day.